All right, let's start over. Hey everyone, welcome. This is the seventh Oasis workshop. We're going to be talking about databases, what they are, what kinds there are, why we use them, and then how we use them. So after that, we're going to be having some time for questions. We're going to be playing a basic Kahoot, and then we're going to be going through a walkthrough where we're going to be making our own database using MongoDB, which is a really popular database solution, and actually writing the code to connect to that and in our own Node.js application. So joining us today, we have Krish Sharma from the Data Club. He's the vice president. He's going to be taking us through this tutorial and also sharing his experience and talking some more about the Data Club. So you can get involved. And with that, take it away, Krish.
All right, thanks a ton, Chris. So, hi everyone, my name's Krish. I'm the Vice President of the Data Club, and today we'll be talking about databases. But before we get to that, I just want to give people a high-level overview of what the Data Club is and what kind of happens in that club on campus. So we have three different types of events throughout the semester. So we have data science and data analytic project development. So students want to investigate a certain topic using either some sort of statistical learning approaches, machine learning approaches, or just data visualization. We provide support for that with tools and workshops. In addition to that, we have speaker and networking events. So students can meet people in industry who are working in applied data science or developing new data science techniques through research. And we finally have data science related workshops. So those are workshops on topics like Tableau, topics like databases, as well as a couple of other sort of niche areas within data science, such as natural language processing. So if that sounds interesting to you, please go ahead and scan the QR code in the top right or access our Slack chat in the link at the bottom. So with that being said, I'll definitely leave some time at the end for questions about Data Club and what we do, as well as if you have any questions about getting involved. But for now, I'm going to switch over to the agenda for today, which is to first kind of get an overview of databases and understand what databases are used for, different types of databases, and then kind of going through the steps of creating one and actually using a database live, which we'll do at the end with a demo. So the first question is, what in fact is a database? So a database is a way to provide storage for your application data. So that application might be Facebook, where you want to store information about the post that was just made. That might involve image data, such like as a URL at where that image is hosted for your application. It might contain the text, who posted it, when was it posted, and all of this allows you to deliver your app in a succinct manner, but also allows you to gain some information about it on your back end in terms of processing it and making decisions based on it. And the database architecture allows you to keep this data stored in an organized manner so that you can basically leverage this idea of data structures that we've learned in countless CS classes at this point to get a hold of that information and actually extract that information from the storage device. So oftentimes what we do is we host these databases on remote servers, and then we're able to access it using things known as queries. But oftentimes during test periods, we can host it locally in order to do these operations in a device that we can access directly, just so we can debug and understand how this data is being stored. So within the umbrella of databases, there's two main flavors. There's SQL and NoSQL databases, and we'll get into the differentiation between these, but they generally serve the same purpose, which is to store your data and have you be able to access it at any point. But the way we access it is what really differs between these two approaches. So now comparing SQL and NoSQL databases. So what is SQL? SQL is not a database itself, but a language that can be used to query from a database. So what we do is we write some SQL code, which is referred to as a query, and that grabs that information that we specified from the database and returns it to us. However, this isn't what we'll be focusing on today. Today, we'll be focusing on another type of database, which is a NoSQL approach. But first, let's go through a few examples of what SQL looks like. So in order to select some information from our Facebook post, we have a variety of features, right? So we have a variety of properties, and we want to extract only a certain select components of those overall properties of an individual post. So let's say we have a table of posts, and we want to grab the text, who posted it, and the image URL from that table. So what we do is we specify what we want to do, which is select. We specify the columns we want to select and from which table we want to select them. And then in the second example, we're kind of using some of the key features of SQL to shorten our query, and we can use this asterisk. So the asterisk indicates that we want to select all fields from the table, and then we can also filter our query and only select based on certain traits of individual features. So in this case, we only want to extract all of the information for cases where the poster's age is greater than 25. And so this is just like a high level, very brief interview to SQL, but there's a lot more ways to structure your queries in order to get the specific information that you want. So now what's an SQL database look like? So we went over the language, but now what does the database itself look like? So we use SQL to query from them, and the type of database that we query from is a relational database. And so a relational database has tables, and it holds collections of related information. So oftentimes when you visualize these databases, they look exactly like a spreadsheet. So you'll have your columns, which have the information for a certain attribute, and your rows will be certain instances that have information about those attributes. So referring back to this example of Facebook posts, each individual row would be a post, and each column would contain the corresponding information for that post. Now, we also see that there are connections between these tables, and we'll get into how those are related, hence the name relational databases. So each table has these various fields, and so we have those columns that we were talking about earlier, and spreadsheets also have rows. So it's really just the same architecture as what you see on something like Google Sheets or Excel, but we are doing it in a very principled manner. And the way we connect individual tables, so related information, is using something like a key. So let's think about our concrete example again, which is Facebook posts. Let's say we have a post, and for that post, we have an individual user that posted it. Now, in our table of posts, we can identify that user based on their user ID, but let's say we want more information about that specific user. We can use that key, that identifier, to check our posts table and our users table. So maybe our users table includes some different information about the individual poster, for example, what their name is, when they joined Facebook, as well as some demographic information about the user. Now, what we're able to do is use these foreign keys as identity entries, and these foreign keys link to other entries where there are different tables. So what this is referred to as a schema, which is what kind of defines the constraints for how our data should look. So going back to, if you've taken Fundies 1, this idea of a data structure, we're really defining a data structure where we have these individual columns that must be satisfied. So for example, you can say that for a given post, the user must not be null. And what that means is that there must be a user for every single post. And that kind of makes sense, right? You can't really have a post where nobody's posted it. Now, what we are able to do then is also specify these relations between different tables using foreign and primary keys. So primary keys are always fields that are guaranteed to not be not null. And that way you can ensure that for a individual entry, you can get a unique sort of pairing for that key. And so now we can distribute our related data across many tables. So what we're able to do is we're able to have an overall database on the subject of Facebook, and then we can have individual tables such as posts, users, advertisements, and all sort of individual tables that provide information that comes under the Facebook umbrella, but is still distinct from the information provided in individual tables. Now we're going to transition over to NoSQL databases, which is what our demo is going to be focused on. So NoSQL databases don't use SQL. So that's probably pretty intuitive, just based on the name of this type of database. And the way that we store here is using document stores. And so these are essentially just lists of documents, and we can use database-specific syntax for querying. So one example of this is MongoDB. And so instead of having tables, we replace those tables with collections. And so collections hold lists of documents, and each of those documents is an entry that holds some data. So the way to think about this is JavaScript objects and dictionaries. So, your dictionary might have individual keys, and those keys may store data about that document. So this is kind of just based on that high level structure of what a JSON file looks like, or what a dictionary looks like in individual programming languages. So different documents in the same collection can now have completely different fields, right? So we no longer have this idea of a schema. And when we don't have a data schema, it's harder to predict what type of data you actually have. So what you are able to do is you're able to reduce the amount of time that you spend in designing this schema. So you don't have to have this very hard set architecture for how you want to organize and define your data in terms of how you're storing it. And instead of having those schemas, you also have this reduction in the number of relations. And so there's less use of this idea of foreign and primary keys, and you're just reduplicating data in multiple locations. So this kind of makes intuitive sense because you have this idea of schemas, which are a very strict sort of pattern you have to follow in storing data in relational databases. And so then you need to ensure that you're following this approach in order to make those queries with your SQL language, or else your queries might fail and you won't know why if you're not following the proper procedure for storing your data and you're not meeting the constraints that have been specified. And instead, what happens is when you don't have this sort of strict architecture, you start duplicating data because you don't know, there's no guarantees for where that data might be stored. And so overall, what we see here is that a visual relation here is that in relational databases, you have individual tables that hold specific information about a overall topic, and you can connect those tables based on keys. And so this is, again, a much more strict and rigid format in comparison to the second format, which is for NoSQL databases and follows a much more loose approach to structuring your information. So for example, even though you're storing the same type of information in multiple documents, the way it's stored is slightly different, right? So we can see that with the full name versus full name breakdown of first and last name. So now we'll switch over to a little bit different of a topic. So here is basically a question for me, which is talking about a time when I've used and benefited from databases. So, we've been talking about the syntax and the specifics of implementation and representation, but my experience has been really practical with using databases, which is why it's genuinely a skill that's worth to learn. So my experience has been in genetics research. So when we want to understand what type of genes are associated with a specific disease, we can query a database of this information which has been collected from researchers over experimental trials. And so when we want to select for a specific disease that a user has told us to investigate for a downstream pipeline that sort of does more intense analysis using statistical learning and machine learning, we need to ensure that we're extracting the correct data from all of the data that's available. So my application required me to use SQL in order to extract information about the specific genes that were related to a disease, because we had columns that indicated how frequently a certain disease appeared in patients with the corresponding gene sequence. And so what we had to do was extract that information so we could train our models and do the downstream analysis necessary based on this information. So now going a bit more in depth about why we use databases is to store information like we talked about earlier, but at the same time, they're not strictly necessary. It's just another way to present your information, which can be done as a simple text file, which by the definition of a database still satisfies the kind of the criteria for determining whether something is a database or not, which is that you're storing data. So that being said, a text file is far from optimal. And you can think about this when you want to get certain information about a data structure. It's far easier when you have a specific structure of that data to query it and determine whether certain facets of that data structure hold to be true. For example, checking if a race car has completed a race, you can have an attribute is completed, but if you're looking at the race log, you have to scrape the entire file to check if that car has actually finished yet. So it can get extremely convoluted very, very quickly, and spending a bit more time organizing your data at the beginning and defining a database can allow you to speed up the process in the downstream analysis. So the next question here is, how do we actually solve for this problem of databases and storing information? And so database solutions provide a way for us to do that in the cloud. And so we can store large amounts of data, and it's persistent data, which means that it's not going to change, it's efficient to update, and it's easy for a human to read and understand. And many of these resources are free. So cloud storage is becoming more and more accessible. Especially as a student, you have a bunch of free credits. So I definitely recommend leveraging those while you can to learn about these types of technologies. Now, the next part is, how do we create databases? So the solution is these individual database solutions. So a database management system, a DMS, is a piece of software that allows us to create a database to interact with. And so there's a couple of ways to do this. The one we'll be covering today is MongoDB, but there's also techniques, or rather systems, such as MySQL, Couchbase, and Postgres that allow you to do this as well. And what you can do is you can store these databases locally by firing up an instance. And so you can do that on your own computer by installing the necessary software. For example, if you take the database class here at Northeastern, you'll be using MySQL, and you'll have this thing called a MySQL workbench, where you can directly see the tables, you can make queries, you can store the data on your laptop. But today we'll be going over a cloud solution, which is a bit more preferable, especially when you're deploying an application, because you don't want your laptop to be the one that's hosting the application and hosting the database, in the very likely case that you have to turn your laptop off. So now we'll go into a bit more detail about creating databases depending on the specific type of database you want to create. So like I mentioned, one common option for SQL databases is MySQL, and that's one that you'll definitely learn if you end up taking the class here. And so what happens is that it fires up a server, and then you can have multiple databases with multiple tables within each database on your laptop itself, and you can query that just by knowing where to access it. So the same way, when you spin up a create React app and you're able to host it on your local host at port 3000, you can do the same thing with a database on your laptop, and you can find the local host that it's being served at and access that information directly. Now, for NoSQL databases, MongoDB is a really popular approach, but Firebase is as well. So Firebase, I believe, is a solution by Google, or rather it was acquired by Google, and now it's part of this Google Cloud platform that allows you to integrate these technologies across the board for all sort of cloud applications. And what happens here is that the DMS spins up a server that allows for multiple databases with collections instead. So it's really just a substructure that you're concerned with here in terms of the differentiation between SQL and NoSQL databases. So this is kind of a recap slide, just kind of talking about what we've covered so far in terms of interacting with databases. So we use SQL to interact with SQL databases, which makes intuitive sense. And these SQL databases are often relational, and we can use these SQL queries to grab the data, or APIs that convert our queries into SQL specific code. So just think of that like as a compiler compiling it down into a specific SQL query and getting that information for you. For NoSQL databases, we use the provided APIs. So these are a bit more specific to the service that you decide to use. And today we'll be going over one of those services. So overall, databases allow us to store data, access it later, manipulate that data, and this allows us in the overall context of developing an application to enhance user experience by making decisions based on that data, by providing that data back to the user when appropriate, and being able to store this data in tables with well-defined schemas really pays off in the long run by leveraging this fact that you know the sort of organization of your data. And it follows this intuitive definition based on spreadsheets that you can commonly see in the sort of applications that you may design just in Google Sheets. NoSQL databases are a little bit different in that sense, where they have document stores and collections of documents which don't have predefined schemas. So the organization of the data can vary a little from instance to instance, but each definitely has its advantages in terms of scaling and can be created in these forms of database management systems, which are services that are provided by companies and open source software. So with all of that, now we want to open it up to questions and, to give people a short break.
Notice we also have some suggested questions if you're needing some inspiration at this point.
How do you decide in an application whether you want a SQL or NoSQL database?
Sure. So that's a great question. I think, oftentimes you want to decide depending on the scaling that is required. So SQL databases are a bit more difficult to scale because you have to kind of ensure that construct of the data is consistent across across all sorts of the individual attributes that you want to store. With NoSQL, if you have a new introduction of a data type or a data construct, you can dump that into your database without too much difficulty. So in terms of cloud databases being persistent, and this idea of new data not being added, I guess I should clarify here. New data can definitely be added. So databases can be mutated, but this idea of persistence is that it will be consistent across queries. And so you'll go into this idea of ACID when you talk about databases in the class here at Northeastern. And what that essentially means is that you want the changes to be propagated consistently. So if two people are accessing the database, they should get the exact same information until this idea of a transaction, which is when you're mutating your data, is fully completed. So going back a little and answering the other questions in the chat here, Jake, so if there's no image URL, you don't want that key to be required for a specific post. So then in certain cases, you can actually have a null entry for certain posts, which is totally valid. But for example, if you have something like a post ID that uniquely identifies a post, you never want that to be null. Hopefully that makes sense. And then Luke, these free credits. So what I would recommend is that you sign up for the GitHub Student Developer Pack, which is totally free as long as you sign up with your Northeastern email. And then you can get a bunch of free credits as a student currently and, practice on your own. And you don't only get like access to cloud credits for databases, you get a bunch of cool stuff with that as well. So I would definitely recommend doing that even if you're not interested in using the credits for databases specifically.